All right.
All right. So who wants to help me out with this first one? Nameless person from the class. Go ahead.
Would it be 12x plus 12?
Now, you're telling me the end of the problem. I need help getting started with the problem. So how would I write this out?
So we have to do 2x plus 1 plus 2x plus 1.
Okay, interesting. So I'm going to take the 2x plus 1 and then add another 2x plus 1. Where's that other 2x plus 1 coming from?
On the right side. Yeah, the opposite
Okay,
side.
good. So the opposite sides of a rectangle are the same length. So there's two of the sides added together. Good, and then the other two sides, a 4x plus 5 and another 4x plus 5. Good. And so if I want to add all those different things together, so now I'm going to zoom in. And now this looks like one of the type of problem I would have done on Friday. I said I was going to zoom in, apparently I can't. So, when I want to combine these, I have to add like terms. And one of the strategies we used was to, let's say, draw different shapes around terms that match. So I'm going to circle all the ones that have an X. There's one. There's another one. No, that one. Yeah. That one. Yeah. And that's going to help me combine the correct terms. So I've got 2x, and then another 2x, and then a 4x, and then a 4x. I'm adding them. So remember, when I'm combining these terms, when I'm adding them, I just add the numbers in front. So I'm going to add a 2 plus a 2 plus a 4 plus a 4, which was 12. That's right, class. It's 12. Good job.
Yeah.
12 what?
12x.
So when I'm adding, I don't actually change the variable at all. I'm going to keep it as x. Keep it as x to the first power. And now I'm going to go through and, what's another good shape? Triangles.
All right.
I'm going to draw triangles around all of the terms that don't have any x's at all, because they're alike and I can combine them. There's one, there's one, there's one, and there's one. So now I'm going to add the triangle terms. A 1 plus a 1 plus a 5 plus a 5 equals 12. Without an x term on it, just like all of the terms that I added together. Okay, so that would be the perimeter of this rectangle. Now, what if I wanted to find the area?
Like base on height.
It's something like that. Area of a rectangle.
Find the length and the height.
Yeah. So just the base times the height. Only two dimensions on a rectangle. So that would be like for a 3D prism. You'd have the base height and width, or whatever you want to call them. So just the base times the height, or the length times the width, whatever you want to call them. In other words, I've got to take the 4x plus 5 and multiply by the 2x plus 1. And how do I do that?
Just add the, oh wait, no, you multiply the x's and then multiply the non-x's.
Turns out it's a little bit more complicated than that. And this is actually what today's lesson will be about. Instead of adding this time, I want to multiply a couple of these polynomials together. What does that look like? So that's what we're going to get into today. It'll help us do things like find areas and even volumes if we wanted to add a third dimension, something like that. So for today's lesson, we're going to focus on multiplying polynomials together. Which means I should probably pass out this paper, which I'll do now.
Do we need to turn the center or anything?
No. And the same paper will go out Okay. So one simple example, and we actually did this, we did problems exactly like this in the last lesson. We didn't think about it as multiplying polynomials together, but that's actually what I do anytime I distribute. So let's start on this first problem. So I'm going to take this 2, which is a really, really, really simple polynomial. Remember, when it's just one term, we call it a monomial, as in one omial. So I'm going to multiply this 2 by each term inside the parentheses. So 2 times 3x. Now, you're probably not going to write out this intermediate step. I'm going to write it out just to make sure I'm showing my work. So I'm going to multiply the 2 by the 3x. Then I'm going to multiply the 2 times the 1 with a minus there. So minus 2 times 1. So there's my distribution for the left-hand side. Now, I'm writing in an extra step. So just bear with me, if you will. And then what I'm going to do is distribute not just a 4, but a negative 4. So I'm going to multiply a negative 4 times 2x. And I'm going to multiply a negative 4 times a 5. Notice how when I'm multiplying by a negative number, I leave a minus there instead of a plus. Okay. And now we'll actually write down the step you probably started to write down immediately. What is 2 times 3x? 6x. What is negative 2 times 1? Negative 2. And then negative 4 times 2x? Negative 8x. Negative 4 times 5? Negative 20. Okay, so let's make sure we're all writing down these examples. Okay, so what I just did, or what you just did, you actually did it twice, is you multiplied a monomial by a polynomial. So essentially all we're doing in this lesson, at least the first part of the lesson, is distributing. Something you've already done before. Only we're going to start distributing more and more complicated things, like x, or x squared, or x times y, or eventually on the back page, we're going to distribute not just one term, but an entire polynomial.
Oh, shoot.
Right? Okay. And of course, at the end of the problem, we might simplify a little bit if we can and combine like terms. Are there any like terms to combine here? Let's see. That guy and that guy. I want to be careful that I capture the negative with the 8. So a 6x and a negative 8x would be a negative 2x. Then a negative 2 and a negative 20 would be a negative 22. Because negatives are confusing, as we all know.
You are correct.
Okay. Question? When you say divide it, what do you mean?
You want us to simplify, so negative 2 divided by 22.
So these are subtracted here. And so because they're not like terms, there's no way to simplify the addition or subtraction. We will divide lessons, but here it's just adding and subtracting. Yeah, good question. Now let's try the same thing when we're distributing an x. So it might look a little bit different, but the process is going to be the same. I'm going to take this x and multiply it by each term. x times x cubed. And again, I'm going to go ahead and write out this extra step. When you're solving this by yourself, you might not actually write out the step I'm writing now. I just want to make sure that I'm showing my work. X times 3x squared. I'm going to steal the minus sign and then write x times 5x. And then x times 6. And steal the plus. So what I'm doing again is multiplying each term inside the parentheses by x. Distributing, in other words. Something we've done before. Something else we've done before is multiply something that looks like x times something that looks like this we actually had on our last test. When we're multiplying these two things together, does anybody remember what we do with the exponents? Remember, this is a secret 1. The 1 and the 3. You just add them, is correct. What's 1 plus 3? It's not 17, it's 4. But good try. X times 3x squared. So look at the number parts separately. This is a 3 times a secret 1. What's 3 times 1? 3 times 1. And then x to the first times x squared. Add the exponents. 1 plus 2 is 3. Good. Okay. So this step, again, is not something new. It's something we've actually done before and was on the last test. A negative 1 times a 5. And then x times x. Or x to the first times x to the first. 1 plus 1 is 2. And then how could I write x times 6? What do I even multiply together there? There's not another x to multiply the x by. There's not another number to multiply the 6 by. Yeah. So we could just write it as 6x. Which is the same thing as, 6 times x, which is the same thing as x times 6. It's just a simpler way to write it. And now let's look and see if there are any like terms we can combine. Do any of these terms have the same variable with the same exponent? Nope. Therefore, we cannot combine any of them further, which means we're done with that problem. Okay. So we're going to try a couple more. Let's try this one. Looks tricky, right? But it's basically two simpler problems. Let's actually do the one on the right. I know you saw a fraction and it scared you. So let's do that one together. And then I'll let you try this one on your own. So again, we have two problems, kind of like the one we just tackled. I've got a 5x that I've got to multiply by a 3x plus 1. And to do that, I distribute. So 5x times 3x. Remember, multiply the number parts together. 5 times 3 is 15. Actually, I said I was going to write that extra step in. I'm going to write it in. I'm going to take a 5x times a 3x. That's my first operation. And then I'm going to multiply a 5x times a 1. So we're breaking this complicated operation up into simple operations that we've already learned how to do. Or in other words, 15x squared. 5x times 1. What do I do there? What's anything times 1? Itself. 5x times 1 is just 5x. So we simplified the left-hand side. Now let's do it again. This time for the right-hand side. Oh no, a fraction. So I'm going to distribute again, and I'm going to make sure that when I do, I bring the negative with the 1/2. So now I've got negative 1/2 times 4x. So minus 1/2 times 4x is going to be my first operation. My second operation is a negative 1/2. See how I stole the minus sign there? A negative times a positive is a negative. So negative 1/2 times 8. Now, I was nice to you and gave you a simple fraction like 1/2. So when I multiply my number parts together, what's 1/2 times 4? Or in other words, what's half of 4? 2. And is it going to be a positive or a negative?
Negative.
A negative. What about x's? Do I have any x's there?
Yeah.
How many?
1.
So x to the first. And then negative 1/2 times 8. Again, it's half of 8. What's half of 8? Yeah. So we'll end up with a negative, and from the negative times a positive, and then a 4, because 4 is half of 8. And now I look to see if there are any like terms I can combine. Does this x squared have any x squared friends it can combine with? No. And that's sad. What about this 5x? So this 5x, let's see, what shape can I draw? A
Yeah.
sign.
No, it's like one of the little things that you put pow in Batman. Like when they punch someone, it goes pow.
What would you call that?
I don't know. Isn't it like
An onomatopoeia.
Bubble. Oh.
Bubble. So these two will combine. What's 5x minus 2x? 3x. Good. And then the negative 4 won't combine with anything, and neither will the 15x squared. So I have combined all of the terms I could that were alike. And it's a positive 3x, so it'll have a plus in front of it. And once I can't combine any more like terms, or multiply any pieces together, I'm done. Any questions before we move on? Is this feeling doable so far? Good. So again, none of the individual operations we're doing are new.
Pardon the interruption. Would you Alexa Ramirez to the main office? She will return.
Yes, I will. Thank you.
Thank you.
All right. Now this time we're going to distribute an x and a y together. Oh no. So first I'm going to multiply the x and the y, or xy, times an x squared and a y. That'll be my first operation. Second operation, I'm going to steal the plus, a positive and a positive. I'm going to multiply this xy by that xy. And then for the last operation, xy, a positive and a negative, I'm going to steal that negative sign because my answer should be negative. I'm going to multiply xy times xy squared. Now let's see if we remember how to do this. So when I'm multiplying, kind of like we do when we have numbers and variables mixed together, we break it up into smaller problems. If I've got a 5 and an x and a 3 and an x, I multiply the numbers together first. 5 times 3 is 15. And then I worry about the x's. I can do the same thing with x's and y's. So first I'm just going to worry about the x's here. X to the first times x squared. Add the exponents. That's x to the what? X to the third. So I just multiply the x's together, and then I'll multiply the y's together. Break it up into two separate problems. Y times y. Y to the 1 plus 1. Y to the second. Same thing for the middle term. See if you can do it in your head before I do it.
What goes in between the x and the y? Is it times or plus?
Yeah, so these are actually multiplied together, even though we don't always write it when the variables are next to each other.
In
They're not-
between
they're like
the nuance or the x.
Plus.
No.
Here?
Yeah.
So I could put a times there if I wanted to.
Okay.
I can also just write them next to each other. It means the same thing.
Okay.
Let's see, I got x squared, y squared. Is that what you got?
Yes.
So x to the 1 plus 1, and then y to the 1 plus 1. Then my last answer should be negative. So again, try it in your head first before I write it down. X times x. X to the... I got x to the second, and then y to the 1 plus 2 is third. Y to the third. Is that all you got? Thank you, 2 people. All right, quick pause for questions.
So xy is pretty much the base. No, like they're the same. So xy is 1 plus another xy minus another.
Yeah, so I have 2 different bases here. The x is a base, and the y is a base.
But
So
you're pretty much just saying that it's multiplied together.
yeah,
So they can practically. So you don't really have to put x times y.
exactly. So we don't have to put an x times a y, just like we don't always put a 5 times an x when we write 5x. We just write them next to each other, and that means they're multiplied.
Okay.
So yeah, same thing with x and y here. If it says xy, it could be like 4x or 7x or 10x. It's just another thing multiplied by x. Okay. So this is the first page. This is the first part of your lesson of 7.3, multiplying by a polynomial. I'm going to move this paper down so we can look at the title again. Multiplying by a monomial. In other words, all this really is the distributive property, and then at the end you combine like terms if you need to. So none of those individual pieces are new. And then we flip the paper over. Okay. So this time we are multiplying not by a monomial, but by a binomial. Bi, of course, like a bicycle, meaning 2. In this case, 2 terms. Okay. So when I do this, I will still be distributing. And there are actually 3 different ways we could think about this. So for this first example, I'm going to start it up here, because the way I write it the first time is a little bit longer than the way I'm going to show you how to do it. So for this first step, you don't need to write this down. I just want you to watch to see if you understand, so that when we do the second method, it'll make sense. Okay, so this time we're going to distribute, but instead of well, that's all I'm going to say. This time we're going to distribute. So I'm going to take the thing out in front, which in this case is an entire 2x plus 1, that whole thing, and I'm going to multiply it by each term on the inside. So I'm going to take the thing in front and multiply it by each term. So again, for this first step, don't write this down. I just want you to watch and see if you understand the process. So my first step is going to be to take a 2x plus 1 and multiply it by the first term, which is x. And if I want to multiply by something complicated, I can use parentheses to show that. Now my next step is going to be to take that 2x plus 1, the whole thing out in front, and multiply it by the next term. I'm going to steal the minus. So I'm going to multiply that 2x plus 1 by this 3. So I'm distributing again. Take the thing out in front and multiply it by each term. Now, what do you notice I would have to do if I want to go on to the next step?
So first thing to do, there's the subtraction sign, but just that usually means like the -1, so you have to distribute.
Yeah, and so if you want to avoid that, one other thing you could do is put a plus. Oops. And just call that a -3, if you like that better. Because, yeah, that would be a little bit complicated. So maybe we'll just leave the negative on the 3, and that'll simplify it a little bit. So again, that's the 2x plus 1 times a -3. So what would I have to do to go on from here? Does this look kind of like one of the problems on the page before? Yeah. So from here, we would just be distributing again. I would do an x times a 2x, and then an x times a 1, and then a -3 times a 2x, and a -3 times a 1. So this would be the long way to do this. We would distribute and then distribute again. So I'm going to show you two methods that we can use to shorten this process at least a little bit. So these two things you'll probably want to write down in your toolkit. We would be multiplying polynomials together, which is on the second page at the top, I believe. So I'm going to show you two methods. Some of you will prefer method 1. Some of you will prefer method 2, but all of us need to understand both of them. So I'm going to call method 1 distribute one term at a time. Distribute one term at a time. And I'll show you what I mean. And essentially what we're doing is we're skipping to this second step. So here's an example. So method 1. So instead of distributing the whole 2x plus 1 thing as a big chunk, and distributing the whole chunk to the x and the whole chunk to the -3, what I can do to make this a little bit simpler is just distribute one term at a time. So in other words, I'm going to start by distributing the 2x. And I'm just going to ignore the plus 1 for now. So I'm going to do 2x times x. And then 2x times a -3. And again, there are multiple ways to deal with this negative sign. I could look at these and realize that, hey, when I multiply a positive times a negative, I'm going to end up with a negative and put a minus in front of it. Or I could just always write a plus and then write the two things I'm actually multiplying together. 2x times -3. It doesn't really matter. It's the same thing. So I'm going to multiply both of those things by 2x. So I have distributed the 2x, but I'm not done. There's something else I have to distribute. I have to also distribute this 1. Can we put those away, please? Thanks. So now I'm going to distribute the 1. So when we say distribute one term at a time, I'm going to distribute each term from the left-hand side one at a time. So what's 1 times x? You're right, it's just x. And then I'm going to do 1 times -3. So this is method 1. Distribute the terms one at a time. And if you've seen this before, which some of you may have in middle school, a lot of you probably didn't, some people also call this the FOIL method. the FOIL method, because I start by multiplying the first two terms together. So the first term from each side, 2x times x. It's the first one from each side. The 2x is first, the x is first. So f is in the first two things. 2x times negative 3, those are the terms that are on the outsides. O for outsides. And then I multiply the inside things, 1 times x. And then I multiply not the first two things, but the last two things, the 1 and the negative 3. Which conveniently spells the word FOIL, which is fun to say. So if you hear me say foiling something, that's what I'm talking about. So you might add that word to your toolkit, just in case I say it, so that you'll know what I was talking about. The FOIL method. It's just distributing one term at a time. And then we'll simplify. All right, so 2x times x would be 2x squared. 2x times negative 3 is going to be negative 6x. 1 times x is just x, or 1x. I'm going to leave it as 1x. Thank you very much. And then 1 times negative 3 is negative 3. And then I'll ask myself, can I combine any of these terms? Are any of them alike? Do any of them have the same variable part? Do you see any terms that are alike there? Which ones, Jack? Yeah. I'm going to draw them inside clouds this time. Except my clouds look just like the pals I made. There. Nope. This is when you learn that your math teacher is bad at drawing clouds. So the 2x squared doesn't combine with anything, but the negative 6x plus 1x what's it going to be? Negative 5x. And then the minus 3 doesn't combine with anything.